So most people write software code without considering what can go wrong. You may think that if you're doing everything correctly, then theoretically your software should never fail. But in reality, all software runs on hardware, and everything that touches the real world has the possibility of failure. So when you're designing software, things inevitably could go wrong. You can't assume that anything is always going to work. If your device absolutely cannot fail, you need to consider building fault tolerance into the system. So I asked Jordan to sit down with me and talk to us a little bit about shedding some light on what fault tolerance is and some best practices so that you can implement it in your own systems too and have the right frame of mind next time you're programming a system that can't fail. So Jordan, just kind of give us a little background on what is fault tolerance.
Fault tolerance is the ability of a system or application to continue operation after a fault, error, failure has occurred and has been detected. The functional operation may be degraded a little bit based on the severity of the failure, but unless the severity of the failure requires a device to enter a fail-safe state, you could probably recover and either retry or continue operation and keep your system going. Fault tolerance is normally sought after in high availability or life-critical systems.
Okay, so if you're creating a critical system, for example, like a medical device or some kind of industrial controller for like the process automation industry, where do you begin creating or building fault tolerance into the system?
First, you need to start analyzing what could go wrong. Like Murphy's first law, if anything can go wrong, it will.
And when you mean that, you're talking about the hardware and where it touches the outside world.
Something's going to fail at some point, and you need to be prepared for it. Really, risk management is where this starts. You need to determine what can go wrong in your system, how critical it is, and can you fix it, or do you need to fail so that no one's going to get hurt or an explosion would happen or something along those lines.
Okay. So when you talk about something going wrong, that could be something like communications with an outside system. That could be like memory sectors going bad on the system that you're actually running on, or things like that. What do you mean by handling it, and how do you recover from it?
Well, the first step is being able to detect the error. Like in communications, we run CRCs or checksums to make sure the message you're getting is valid. For one, could get being corrupted or whatever.
So a CRC, by the way, is what?
Cyclic redundancy check. It's verifying that your bits, the bits weren't modified in transmission, pretty much.
All right, so catching single bit or couple bit errors.
Yeah, correct.
Okay.
And once detected, it needs to be recorded. A lot of times we see systems where error handling is an afterthought, and an error happens. Yeah, you get that it's an error, but where did it happen? No, nothing's recorded. And then when you're trying to troubleshoot it, you have nothing.
So basically, when the device comes back into the programming house from the field, you have nothing to go on to try and recreate it.
Yeah, now this doesn't really happen in a system that's built for fault tolerance because, the risk management and the thoughts put in ahead of time. So
you're anticipating something could go wrong and trying to collect the information so you can figure out what it was.
Yes, making sure you have everything you could possibly need in the event something fails.
So what are some basic what's a thought process or some steps for, do you retry, how do you do that?
Once it's detected, definitely it should be recorded, and then you take steps to either retry, recover, or fail safe. I mean, depending on the severity, and kind of in that order. A lot of times people just retry, like in message communications. If there's something you can do to recover, either switch to another sensor that's in the same area, or if there's duplication in the system, or if there's nothing you can do and it's critical to the operation of the system, you have to fail safe so that no one gets hurt.
So you bring a human in to try and remedy the situation.
You bring a human in, or a controller knows to shut, most of your sensors or devices in this scenario have a fail-safe state, or you tell it what the fail-safe state is. Like a heater would fail-safe off, probably.
Or a valve would fail-safe close.
Close, depending on what it's used for, yeah.
Okay. All right. So what's a common retry pattern?
For some reason, the thing we see the most is 3 retries. And there's no real reason for it.
Other than it's one more than trying one more time?
Yeah, pretty much. I mean, you can do 5 and 10, but it depends on the situation and timing, criticality. If you're doing things every 5 seconds, retrying 10 times, that's 50 seconds. That's way too long.
Oh, right. So if you're going to fail safe, you don't want to try for a full minute while some process is going out of control.
It's time dependent and, how fast you can retry.
Okay. And also I'd imagine too, if you're trying to close a valve, for instance, and you're waiting on it to close, don't retry in 3 times in 1/10 of a second if it takes the valve a second to actually close.
Yeah.
So just, you have to kind of suit the retries to the application, right?
And everything should be ironed out if you do the risk management right. You should know some of these timing characteristics and take that into account when you're building the system.
Okay. So let's try and paint a picture for anybody that's going to be in this situation. Start, if you could, like what's a real life situation everybody could relate to where fail-safe would be important, right? Think about being fail-safe is important.
Well, one thing that everybody probably comes into in their daily life is thinking of driving a car on a highway at highway speeds. If some critical part of the system would fail, do you want the car to come to a dead stop, or
Probably
do you want it to allow you to get safely off the road? Say your tire blows. Now, because I guess it's because the wheel is round, but you can still drive it to a safe place, whether you're going to do damage or not. But it's going to let you fail safe, get to a safe spot.
Okay, so it doesn't, when the TPS sensor realizes that tire's blown, it doesn't shut the car off.
Yeah, it doesn't lock the brakes up or anything like that.
Gotcha.
Yeah.
So that sounds like kind of a no-duh sort of example in real life, but don't we see this when people are programming things? They don't always think about these sort of considerations when they're programming, say, an industrial control or something like that.
Correct. Yeah.
Okay. So what would be an application that we've seen in, let's say, an industrial controller that really should be in almost any situation you should probably think about building fault tolerance into? Say communications, or say, being thread safe between operations. What sort of things always you should build fault tolerance into?
Anytime there's critical communications with a sensor or another controller, another device, you should definitely be checking the validity of the data, the message, and making sure the values are in range. If you have a temperature sensor that all of a sudden jumps from 0, like say 50 degrees C to well over 100, 200 degrees C in less than a second, that's not normal operation. Temperature doesn't normally change that fast.
It can't happen in the real world, so you should try again. Right?
Yeah, try again. Make sure that was a good reading. If it continues, say 3 times, or depending on the timing, you need to fail safe. If it's a critical, like a laser, if a laser's overheating and all of a sudden it hit, I don't know, way out of range that it could possibly cause damage, you gotta shut it down.
Okay. So kind of looping back to what we said at the beginning, anytime your code touches the outside world, you need to think about fault tolerance. Whether that's reading and writing to memory, which could go bad, or controlling the laser, which
or
could
a hard
overheat.
drive or flash, or anything that's critical to the operation of the system.
Okay.
You need to take care of.
So bringing it back around, 3 main points to remember about fault tolerance is design it into the system anytime that your code touches the outside world. That could be third-party libraries, external sensors or hardware, onboard resources like RAM or flash or hard drive, or especially any time that a user might input into the system, right? Then always think about those 3: retry, recover, and fail safe, in that order. And remember, failing safe can include duplication of hardware, or actually even where you store something in memory, and use those levels of protection accordingly. Third, make sure whichever way you're going makes sense for the process. Don't retry so long that a process could go out of control, but also don't retry so fast that you could just wait a few more moments for a valve to close and maybe just record that it's a little bit sticky. So make the approach suit the actual application. So thank you everybody for taking the time to watch this. Thank you, Jordan, for taking the time to talk to everybody about this a little bit. If you find yourself needing some sort of help implementing fault tolerance into a system that you're working on and you don't know where to start, drop us a line in the comments, or you can always email us at info@psi-software.com. Thanks.
If you found this video to be helpful and would like to learn more, or if you'd like to learn about another specific software development related topic, let us know in the comments below, or send us a message at info@psi-software.com.